All right, I think we'll get started then. Good afternoon. Almost end of the day. Almost end of the day. So I'm very excited to be here. My name is Arun Gupta. I work for Amazon. And today we're going to talk about a Java developer's journey in Kubernetes land. How many of you are Java developers? Woo, almost 109% here. That's very typical of Devoxx anyway. And that's the reason I love coming back here. That's the reason Amazon is here. So when I kind of started building this talk, my thought process was, I'm a Java developer. I need to containerize my application. My CIO, my CTO is sitting on my head and saying, Kubernetesize this application. What is this Kubernetes thing? So this talk is going to be meant for Java developers who want to go on that journey. As Mark said this morning, take the red pill, follow my lead. I'm going to take you down the rabbit hole, see how deep it goes. Okay. No slides here. It's going to be a purely GitHub-driven talk here. This is where the GitHub repo is. So feel free to mark it, star it, fork it. We love contributions. This is built out in the open source. So take a look at it. That's where all the code is there. I'm just going to walk you through and hopefully convey a good story over here. Okay. It's on AWS samples. Search for Kubernetes for Java developers. It's a very intuitive name in that sense. So you can look at it. A few stars, few forks, but I would love to see more stars and forks by end of the session, hopefully. Now let's take a look at it, what we're going to do. I'm going to introduce the application, what application we're going to do here, talk about how do we build and test that application using Maven. That's a typical Java developer's workflow, so we'll talk about that. Then we'll say, all right, now I need to containerize this application, sort of my step one into the journey. What are my options? What are my concerns? What are my constraints that I need to be aware of when I'm Docker packaging this application? How can I be conscious about the Docker image size, particularly if I'm building a microservices-based application? Then those applications are being downloaded left and right on my multiple hosts. The image size needs to be lean. So look into those constraints as well. Then I'm saying, OK, now I need to build and test this on Kubernetes. So what are my options of running Kubernetes locally on my laptop? How can I get started with that? I've been debugging my application using IntelliJ when I'm building my Java application. How do I bring that same paradigm using an IDE? I'm using IntelliJ as an example, but by all means, this is applicable to all IDEs as well. Eclipse, IntelliJ, NightBeans, whatever your favorite IDE is. Use that. All right. All of this experience so far is local, in the sense you've been building this application on your local laptop. Now I want to take it to the cloud, and I want to deploy it. For example, in our case, we deployed an Amazon cloud or AWS cloud. So what does my experience look like? Now I have a Kubernetes cluster running on my local machine. I want to fire up a Kubernetes cluster on my cloud, and then migrate the exact same application from my local desktop to the cloud here. Okay. I've done that. Now I want to do cross-cutting concerns. I have applications running in multiple languages. I want to avoid the framework explosion around logging, metrics, CI/CD, or canary deployment, or tracing, or monitoring. All of that I want to do across my microservices, independent of the language. So we'll take a look at some of those approaches. And finally, given upon time, we'll talk about chaos engineering around Kubernetes, which is a whole topic by itself, and then talk about what are my options around deployment pipeline. So my hope is by end of this session, you at least understand sort of what the current lay of the land is, what are your options, and what can you do with it. Okay? I don't intend to do a lot of coding in this session, mostly talking so that I can lay out the work for you, and then you can literally fork this repo and start building this stuff on your own. So in terms of application, it's a very simple application. Let's take a look at it. I have a simple Maven-based application here. I have a greeting controller. It's a Spring Boot application. So by all means, you can use whatever kind that you want. By design, the application is very simple. It just returns hello, hello world. So nothing fancy, but a simple REST-based API it returns a response back to you. And of course, I don't need to show what the application looks like here. Let's take a look at my POM XML. Usual Spring Boot artifacts here. This is Jib plugin, and I'll talk about that a little bit later when we get into this. You don't need to add this in here, but I always add it as a convenience so that I want to put everything that I do in my repo, nothing in my mind, nothing in my instructions. It should be just damn automated. I should be able to click a button, and then everybody should be able to reproduce it. That's the general design practice that I follow anyway. All right, so the first step really is, we want to make sure that our application is live, it is up and running. So we go here, and here is my repo, basically, where I've forked it. And I'm going to go to my app directory, and I will say maven spring-boot:run. So this is going to build my application. It's going to fire up my Spring Boot application at port 8080, and I can say localhost:8080/hello, and that will get me the response. So let me open up a new tab here, and I can say curl http localhost:8080/hello. I get a really simple response, hello. You may say hello app, but no, app is just the prompt part of it. So hello is the response here, okay? So this is only the response, okay? This is app is the prompt. So let's get rid of this application so that our port is free in case we need to start it up again, all right? So very simple. That's the usual flow that we are used to. Now, I need to create a Docker container out of this application because Kubernetes can use an OCI-compliant containers. Docker is by far the de facto way people build, package, containerize their application. And yes, Kubernetes is an OCI layer, or Open Containers Initiative, that defines a standard. And Docker is a compliant format, but by far, as I said, Docker is the standard way people build and containerize their application. Now, in order to containerize your application, there are multiple ways by which you can do that. One is, I'm a Java developer, I'm using Maven, Gradle, whatever build tool you're using. You have those Docker Maven plugins that fit right into your POM XML, and then you can fit them into a profile or tie the phase and the goals together so that you can say Maven package. In addition to packaging your jar file, it'll also generate your Docker image. Those are really talking to your local Docker daemon that is running on your machine. In my case, of course, is Docker for Mac. So you can fire it up, and then it builds the image to your Docker engine, essentially. The other way is you use Dockerfile. I ran a survey, I think, 5 weeks ago, and I asked people what tools do they use. There are a variety of tools. By far, 70% of the people said they use hardcore Dockerfile on how they package their application. Well, what is Dockerfile? So let's take a look at that. So switch to English, please. And I'm going to use Dockerfile here. So what Dockerfile is, it's basically a text file in which you basically put a bunch of instructions guiding on how to build the Docker image. In terms of Docker, it uses a base operating system. I'm not going to go into what Docker is, but the very first statement in Docker is from, which says, what is your base layer? That base layer could be an operating system, could be an image that is produced by the IT department, where they're using a base operating system and installing all the relevant libraries, or it could be a base layer, for example, for OpenJDK, or whatever you want, because then you have a preset libraries already baked into it. So you start with from, then you put commands, copy this file, install this package, install this dependency, and then you say run. You can have only one run. Well, you can have multiple runs, but the last run is the one that is effective. And that's sort of the single point of entry for your Docker container, essentially. Okay? So what people do is they write a Docker file, and then they give a command that, OK, use this Docker file to build my Docker image. And that Docker image is then built to your local Docker engine, essentially. Okay? So you can see the list of commands that are over here. So that's one approach. Now, if I'm using Maven, let's say I want to give this Maven project to somebody who may not have Maven installed. How do I do this? So that's sort of where the Docker multi-stage Docker file comes in handy. And what is a Docker multi-stage Docker file? Essentially, in a Docker file, you can have multiple from statements. So let's take a look at one of those sample here. So I'm going to go to my app directory, and I'm going to look at Docker file here. So here I have two from statements, one on line 1 and one on line 8. The line 1 basically says, OK, use Maven as the base image. Now, this is published on Docker Hub, so I don't really care about. That is just getting downloaded on my machine locally. So I'm using Maven 3.5 JDK 8 as my base image. Now, for the first time when you build the image, you really download, particularly using Maven, you download the entire internet on your machine. Now, if you do that using Maven base image, it's a base image, so there is no Maven repository available there. So unless you do volume mapping using Docker, the cleanest way that I've seen people doing this is they have their own Maven repository packaged as m2tar.gz, and they put it into the Docker image itself, so that every time you're building the image, it's not trying to download the Maven dependencies. Then I just copy my source code, and I run, say, OK, Maven in the batch mode, just package my application. So that's my stage one. Well, what defines stage one? The beginning of a second from statement defines the beginning of stage two and end of stage one. So now what I'm doing is, this is my stage two. I'm saying use OpenJDK 8:8 JRE. A big design pattern that I see in customers is they use JDK as a base image. Think strong. Do you really need JDK as a base image? JDK is compiler and runtime. Do you need a compiler at runtime? So that could really significantly reduce your overall image size. So in this case, I'll talk about it, but essentially I'm explicitly using OpenJDK 8 JRE as a base image because I just need runtime. It's just a jar file. Then I'm exposing certain ports. This is the application port. This is a debug port. And on my stage one, I defined a phase or stage name called as build. So I defined build as a stage name, and then I'm saying from the build stage, target directory, copy into opt target. I set up the target directory, set up some Java options, which is basically for my debugging. That's the usual way I do it in a Java world as well. And then I say just fire up my war file because my work directory is set. So I just say java-jar app war, and that's it. So that's basically my simple Docker image. And with that, I can say, here's my Docker image. It's going to do the whole thing for me. I can give this Docker file to anybody and then say, you know what, you want to have a reproducible build. It'll download the Maven image. It'll upload the Maven repository and all those things. And then it'll create a reproducible Docker image for you. So that's kind of cool. Another approach that I learned about recently as well is, which is pretty cool as well. Now, there are advantages, pros and cons of this because you need to have a clean m2.tar.gz that you can upload to your Docker image, and then you may not have that access. Then you can't you cannot put that into a GitHub repo because M2 has a lot of dependencies. You may not have license to redistribute those dependencies. So there are issues around it. And most of the time, what you're doing is you're changing your application code, not the underlying dependencies. But this puts the whole thing, if you understand how the Docker imaging works, it creates multiple layers. But most of the time, when you're only changing the application code, but it still builds the entire thing as one image, and that one image, in God forbid, in Spring Boot case, just for Hello World, is like 50 megabytes. And it uploads the entire image into the repository. And so it could take a longer time to build that image and then push it around across your different hubs. So the other alternative approach that I've seen people using it is Jib. Now, Jib is, again, a Maven plugin, essentially, and that you can plug into your Docker file. So in this case, for example, that's the plugin that I was showing earlier. So if I go back here, here's a Jib plugin. I have put this into a simple Maven profile here. And the main advantage of using Jib plugin is, first of all, you can tie it into your phase and goal. So you can say Maven package, and this will also generate a Docker package, Docker image for you. One of the advantages for Jib is particularly that you don't need Docker host. Because if you are a Java developer, if I'm asking you to download Docker host or Docker engine, you don't really, it doesn't make sense. Why? Because I want to build a Docker image. So the advantage of Jib in this case is it actually builds an image and pushes it to a Docker hub, which is the default Docker registry. So you don't really need any additional tools. So that's one of the advantages. The other big advantage is you don't need to write Docker file. Because when you look at the Docker file, sometimes it kind of scares you what kind of Docker file it is. Because you literally put the entire configuration script into the Docker file. I hope you're not doing that. And even if you're doing it, maybe you're raising your hand gently. That's all right. The other part that I like about Jib is it really takes my application. And then as it's building the Docker image, it's saying, here are my snapshot dependencies. Here are my final dependencies. Here are my application classes. So it really creates them as multiple layers. Now think about your development cycle. Every time you're building stuff, every time you're recompiling, only the application class layer is being updated. So the advantage as you're pushing the code to your Docker hub or whatever your favorite registry is, only that layer gets updated. Let's go back to Spring Boot. So in case of my, for example, in this case here, if I do here, Docker image ls, let's look at our greeting image here, okay? If I look at greeting image here is 490 megabytes. Imagine that entire image being changed every time. Yes, there is base operating system, JDK, etc. But if your application itself, I mean, I can look at more details about this here. So I can say Docker image history, Arun Gupta / greeting. If you look at this, this is about 46 megabytes, but that's my entire application. If your application is a little bit bigger, 100, 200 megabytes, that's a significant part of your image. And with Jib, essentially, that is broken down into your final dependencies, snapshot dependencies, application classes. So the layering is a lot more intuitive and natural to the Java programmers in that sense. So what you can do is you can just say maven compile jib:/build. And because we have a profile specified, so the plugin is specified over there, it'll just build the image. Exact same image, but the layering is a bit different. Now, one of the annoying parts about Jib is it directly pushes to Docker Hub. And I was just experiencing this right before our talk as well, that the logging statements are a bit weird. It doesn't tell me that, OK, it's actually pushing. It just says, yeah, finalizing. So I don't know, finalizing. What is finalizing? Give me more input about that. So that can always be improved over there. The other part of it is the first run of Jib means it's going to push to your Docker Hub. That means it's a network-intensive operation. And if I don't have network connectivity, like I spend a lot of time on the flights, that may not really work for me. So, but then what you can do is you can also say build to the local Docker engine. So there are like ways and targets by which you can have Jib built to your Docker engine. Okay. Now, once you have your Docker image ready, what you can say is now take that Docker image and run it as a container. So let's see what we're going to do. So I'm going to take the command here and paste it into my terminal. And I'll say Docker container. I'm running the container. I'm giving the container a name by -- name. I'm saying 8080 is the port on my host, and 8080 is the port in the container. Map those two accordingly. And I'm saying run it in a detached mode, so -d, and then the image name, Arun Gupta /greeting. So let's fire it up. Okay. Now, if we search for this again here instead of image, now we're going to say container. So my greeting container is up and running. Okay. Now, what I can do is I can revoke that. Go back to my previous terminal, actually, or here. Let me give this command again. I get the exact same output now, this time from a Docker container. So in terms of your journey, what you're doing is you have the exact same output from Java application. Now, Dockerize it. We discuss about the Docker options, and then run the container, and you get the exact same output. So again, binding on localhost here. Okay. So let's go back here, and what we can do is we can free up the port here again. So we can say Docker remove the container. OK, the container is gone. Then comes, I'm looking at it. So if I look at, for example, here, so Docker container ls greeting, actually image. If I can type correctly. So if you look at Docker image ls grep greeting, this is about a 490 megabytes image. Do I need the entire Java runtime? There's a beautiful talk given by Michael Wittstedt, who works at Oracle, who's an engineering manager responsible for Docker and Java together. And I also gave a talk at DockerCon earlier this year, which talks about how you can really constrain your Java image particularly to a lot smaller size. So if you look here, I have given the commands. Now, JDK 9 has modularity, and one of the tools that came as part of JDK 9, or actually JDK 11 we should talk about now, because JDK 9 is no longer available. So if you look at JDK 11, essentially, it has a tool called as JDEPs. Your application doesn't have to be modularized, but you can say, oh, I'm using a Spring Boot application. The Spring Boot application depends upon such and such module. I don't need the full set of full-blown like AWT modules, for example. So in this, what I'm doing is I'm saying JDEPs, here are the print the module dependencies for target/app.jar. So if my application, take my application, print all the module dependencies for that. And in addition, This is not very clean, but it's saying include these modules as well, because this is a pre-baked set of modules that is required for Spring Boot application. Ideally, it should be able to do a recursive dependency and figure out what is a complete set of modules. But until Spring Boot is JDK 9 modularized, for example, we'll have to kind of specify the set of commands this way. So all I'm saying is, here is a set of modules that my application depends upon. We're going to add the modules using JLink. And what JLink is going to do is take the list of those modules and create a custom JRE for me. That custom JRE is for me, for my application. So that's what is important to me. And now what I'm going to do is I'm going to take that Dockerfile JRE, which I created. So I go back here into my app. Let's take a look at Dockerfile JRE. All I'm doing is, instead of using OpenJDK JRE, because I don't need the full-blown JRE, I'm using Debian 9 Slim. So that, a lot of things here. So Debian, which is a leaner operating system, which has a further slim version. So I'm taking that tag. I'm just copying my target app.var into the root. The JLink will produce a custom JRE with a runtime in there, and I'm going to copy that runtime. And then now the way I fire up my application is using that custom JRE. Why would I do that? Well, the big advantage of that is, look at the image size here. Instead of 490 megabytes, I'm getting 162 megabytes, yet having everything that matters to me. So this really cuts down your image size to 1/3 the size. You can do a lot of fun things with here, say by stripping the debug information if you want to. You can start using class data sharing, lots of other things that you can do to cut down that image size. But I think that's a pretty reasonable size reduction already. So I would highly recommend taking a look at that, my DockerCon talk, which is on my Twitter handle as well. Okay. Now I'm switching gears. So I've understood sort of what are my constraints, what are my things that I need to be aware of when I'm Docker packaging my application. Now I need to take that application and deploy it into Kubernetes. So Kubernetes, the way things work is you need to run, first of all, a Kubernetes cluster. I need to run a Kubernetes cluster on my desktop. Windows, Mac, whatever your favorite flavor is. So this is a MacBook. So on a MacBook, what are my options? Well, I can run Minikube, which is basically a VM that you download, and it starts up a single node Kubernetes cluster for you. Or the other option, which is my strongly preferred option, is because I like to have Docker engine running on my machine because I play with it all the time. So here is my Docker engine. If I look at, say, preferences, there's a Kubernetes tab here now. And what that means is Docker used to support only Docker Swarm as sort of the orchestration layer. Now it also supports Kubernetes as an orchestration layer. So literally all I need to do is, I can't make this bigger, but all I need to do is click on Enable Kubernetes and say, if I just say Enable Kubernetes, that's going to fire up a single node Kubernetes cluster for me on my machine. That is baked into the Docker engine itself. So that's really cool. And I can say, by the way, from the Docker CLI, when I'm deploying my applications, use Swarm or Kubernetes as one of the orchestration engine. By default, of course, it goes to Swarm, but by clicking the Kubernetes button, it is now deploying to Kubernetes. And here it's saying Docker is running, here it says Kubernetes is running. So to me, that is really cool because I like one throat to choke, whether it comes to tool or it comes to my builds. So now, if we don't apply, so if I go here, now I have my kubectl or kubectl, whatever wing you fall in. If I look at, say, kubectl, I can say config, I can say get context, okay? I say, show me the contexts that are available for me. So what I'm saying is, I have multiple Kubernetes clusters created. Show me what contexts are available to me. What is a context? Context is basically containing the authentication, authorization information for your cluster on how do you talk to a Kubernetes cluster, okay? Now, in this case, it's saying EKS cluster, which we'll talk about in a second, and it's saying Docker for desktop. That is sort of the default name that is being used for the Kubernetes cluster created by using Docker for desktop. So that's what it is. Now, I were to deploy my application here, what would I do? I will take the Docker image that I built it, I'll push it to a GitHub repo or Docker Hub repo somewhere, and then once I push it to the Docker Hub repo, I need to write a Kubernetes manifest. And in the Kubernetes manifest, I need to say, what is my deployment looking like? What does my service look like? I kind of put all those deployment descriptors together, and then I deploy it to the Kubernetes cluster. So essentially what I'll say is kubectl apply -f, whatever my manifest name is, which is a YAML file typically, and then I say apply that. So what this API will do is now it'll send this command to the Kubernetes cluster. Kubernetes cluster will say, oh, in the manifest you said such and such image. It's going to download that image, and it's going to run that image by whatever Kubernetes resource type that you have asked it to run. So let's take a look at one of the manifests here. So here, this is a Kubernetes manifest, and in this case, I'm saying create a deployment, call it the name greeting. Well, let's talk about the template first. In the template, I'm saying what is the template of the deployment? That to each deployment, assign this metadata, and then this deployment has a pod spec, which is basically the pod that I'm creating. This pod has one container, and the container has this name, and it is using this image. Now, this image is the one that we push to Docker Hub, so it's going to download it from there. And of course, it can work with Elastic Container Registry or any other registry of your choice. And then in here, I'm saying that, OK, I want to expose one container port. So this is port 8080, and this is an internal port only. OK. Deployment is one artifact that I create. The second artifact I need to create is a service, because by default, deployment creates multiple pods, and you can scale up and down. But all those pods are given an internal IP address, and that IP address is ephemeral. What that means is if the pod goes down, it comes up on a different host. You don't know what IP address is going to be assigned to it. So that means you need to be careful about using that IP address. And the idea is to not use that IP address. That's where you create a service. And in the service, you're saying, you said for the pod, app::greeting is the label that you're going to specify. In the service, I'm saying, use that label. And any pod that has that label, make it as part of the service. And in this case, I'm saying, expose my service at port 80, and the internal target port is 8080. So these two ports are essentially matching. And finally, I'm saying type::load balancer. What that means is that expose this service in a cloud provider specific way as a load balancer. So for example, if you deploy this on AWS, by default, we give you an Elastic load balancer. If you want an application load balancer, sure, you can do that. You want a network load balancer, sure, you can put an annotation in the pod manifest, and then it will generate an NLB accordingly. ALB is basically done using an ingress controller. So all those tools and manifests are cloud specific, but they're still specified in the Kubernetes manifest, essentially. Okay. Now, think about how you build your application. Your application consists of multiple stateless microservices and potentially scaling up and down, and they're talking to each other. So pretty soon, your application has multiple deployments, multiple microservices. Managing it this way, it kind of becomes hellish experience rather quickly. That's where meet Helm charts. Okay. So what are Helm charts? Well, essentially, Helm charts are application definition for Kubernetes. And all you're doing is, you put all of your deployment artifacts together in a Helm chart, and it gives you templating mechanism. So actually, let's take a look at a Helm chart here. So I'm going to my manifest directory, and I have a my app directory. So this is all of my Helm chart, essentially. And in Helm chart, well, let's take a look at values first. In the values, I'm saying, it's a YAML file, so I'm saying, what is my image name? What is my replica count? What am I, giving some more details about image in terms of pull policy? I'm defining my ports and the service type, okay? Now, if I look at chart.yaml, that is a little bit more metadata about the Helm chart itself. Templates is where most of the relevant information is. So if I go to greeting-deployment.yaml, I'm specifying the exact same manifest, essentially, but using the templating language. So essentially here, I can start bringing more consistency to my application, having a similar release name, similar deployment name. So you can start putting the templates into the values.yaml and using that actually into my deployment.yaml here. Okay. So I'm specifying my image pull policy, internal port, internal debugging port. All of those values are specified. And similarly, in greeting service, I have similar release name, the template labels. And so So the idea is, dry. Don't repeat yourself. If you're specifying the labels and the ports at multiple places, put them into values.yaml and repurpose them into your Kubernetes manifest. So how does it work, really? OK, I got my Helm chart here now. Now I need to deploy that Helm chart, essentially. So what you do is, it's simple. You just say brew install Kubernetes Helm. It's a CLI. So on a Mac, and there are tools available on different platforms. So you install Helm. Once you install Helm, then you need to initialize Helm. At least in Helm 2.0, there is a concept of a CLI, the client-side component, and the server-side component. So the server-side component, there's a tiller, it's a deployment artifact that creates it into the Kubernetes cluster itself. And then there's a CLI, which says, OK, deploy this chart. I'm not going to get into the flow of Helm, because that is, again, a long talk by itself. But essentially, what you do is, you say, Helm, install the application, and you give it the name my app, and you just point to the directory where your Helm chart is sitting. So instead of saying kubectl apply -f blah and blah and blah, here you're saying Helm install one application and deploy. And you still have to manage your deployments and replicas by itself, because these are all still independent artifacts. But at least one way to deploy your application and one way to delete your application, and also bring a lot of consistency in terms of release labels, release names, values, labels, all of that. Okay. And here what I'm doing is, once I deploy the application here, essentially, I'm using some kubectl magic here, so to say. I'm saying kubectl, get me the service. I know the service name is my app/greeting. From that, use this JSON path, give me the host name, and now I want to invoke :8080/hello. And this is 8080 is the port. Actually, it should be 80, because 80 is the one that we exposed in our service description. And then I say hello. So let's step back for a second. We started with a Java application, made sure it works and tested in our environment. Do the exact same thing with your Docker image and container. Then you write a Kubernetes manifest, and then you kind of go on from there to write a Helm chart, and then you deploy it to your Kubernetes cluster. So far, you have been operating mostly, other than the Docker hub part, mostly on your local machine, and that seems to work fine. I want to debug this application as well. So what I'm going to do is, if you're debugging your Java application, usual Java application, what you do is you go to IntelliJ, you say run debug, and you create a profile here. Okay, so you can create sort of a remote profile, and that's what I did. I literally created a remote profile here, and it gives me the options that needs to be specified, because essentially it's going to listen on localhost :port 5005, and it says, all right, this is what you need to specify in your application invocation time, so that we can have the remote VM be connected to it. So all I did is, if I look at it here, in my app, actually in not this version. Well, here all I'm doing is I'm exposing my internal debug port. But when I look at my app itself, which is my Docker file, remember we saw this option? This is the option that IntelliJ gave me that, hey, put it into as part of your application invocation, because that's sort of my application environment. So now when I run my application, I run my application, I invoke the application, but before that, I'm going to attach the debugger to the application, and then it just stops right there. So I'm going to go back to my browser here for a second. So I create the profile here. It kind of shows exactly how you create the profile. Then you set up a breakpoint in the class, because you want to see that what your class variables, etc., look like. And then you access the application, exact same way, and then you will automatically hit the breakpoint. So you can continue to debug your application, whether it's in Java, whether it's in Docker, whether it's in Kubernetes, and that works across all three. Okay. Now I want to get started, and I want to do this application, or I want to deploy this application on a Kubernetes cluster running on a cloud. So for my purpose, I use the AWS cloud. I work for Amazon, of course. So, and one of the things I like about using Amazon is because it is a managed service on Amazon. So we have, at last reInvent, we announced Amazon EKS, or which is Elastic Container Service for Kubernetes, which is a managed Kubernetes cluster on the control plane side. So essentially what you do is you go to the Amazon console or AWS console and say, give me a Kubernetes cluster, and then it creates a Kubernetes cluster and gives it to you. You still have to attach the data plane, which is basically the worker nodes that needs to be connected to the master control plane. But that makes a complete Kubernetes cluster. The big advantage of using EKS is we do upgrades, patching, HCD backup, restore, encryption, all of that, we take care of it for you. You don't have to worry about it, what's going on. And we do the automatic, when the next version comes out, we automatically patch it and upgrade it to the next release automatically, okay? So the idea is, the way at least I create a Kubernetes cluster on AWS, the instructions could be a bit daunting if you look at sort of the documentation. So I typically use EKS Scuttle, just like kubectl, EKS Scuttle. EKS Scuttle is a CLI provided by Weaveworks, which is a very good partner of Amazon. So Weaveworks created this EKS Scuttle CLI. And essentially what I'm going to do is I can create, it kind of gives the instructions on how you need to install the CLI. But my command to create an EKS cluster is EKS Scuttle create cluster. Give it a cluster name, what 4 nodes you want, and the region you want. And now Amazon EKS is available in 4 regions. So you can pick any of those regions. So I think US West 2, US East 1, US East 2, and Dublin. Those are the 4 regions where it's available. If you want Amazon EKS to be available in more regions, I highly recommend talking to your technical account manager and percolate the request up so that it goes to the product manager. We would love to roll out Amazon EKS to a much more wider set of regions, okay? But once the EKS cluster is created, so what I can do is I can say kubectl config get context. It shows me 2 contexts. So let's say my EKS cluster is created on US West 2 in this case. And the context here means it's a EKS cluster using ekscuttle.cio or IO. That's the default name it basically uses. Now, what I can do is ekscuttle config. I can say use context, and I can copy paste this name here. And if you look at, say, get context again, now it says the default context, which is shown by in the very first column, is now switched to the EKS cluster. The typical way that we have seen customers migrating from dev to prod or to different stages is they create multiple clusters, they change the context, and redeploy the application. And that can be very easily be done using a CI/CD tool. So whatever your favorite deployment tool is, you can easily leverage that and say, change the context and deploy it over there. Well, that's one part of it. Another powerful tool that we have seen customers using is by Heptio, with the intent to be acquired by VMware. That company created a tool called as Arc. So if we go here, so Heptio Arc, this tool is actually meant for disaster recovery, but essentially what it does is, I mean, if you understand the Kubernetes architecture, all of the Kubernetes persistent state is stored in etcd. So what does Heptio Arc does? Heptio Arc basically takes a backup of Kubernetes etcd and restores it on a different cluster. So that's another way that we have seen our customers kind of migrating from one production environment to another one, whether it's dev to prod, prod to test, test to staging, whatever it is. So you can use Arc as one of the tools over there. You can set up like sort of a cron job to take automatic backups of your cluster. So that's again multiple usages of Heptio Arc essentially. So let's talk about, this is not a deep dive on Istio by any means at all. And I mean, again, this is a talk that can be given for a couple of hours. And I heard there was a beautiful deep dive on Monday given by Matt Turner from Tetrate company. So all these sessions are recorded. All the deep dives are recorded. So if you are interested in Istio deep dive, I've heard really good comments about that deep dive. So I would recommend taking a look at that YouTube. I believe that session is already live. So you can take a look at that one. But what is the pain point that we're trying to solve here? As you're trying to build your microservices, particularly using multiple languages, and also you're trying to do metrics, you're trying to do logging, you're trying to do monitoring, you're trying to do traffic control. By traffic control, I mean I want to do a A/B testing or blue-green or red-black, whatever terminology you use. Now I want to introduce a new version of an app, and I want to guide only 5% of the traffic to that new version, where 95% traffic is being served by the old trusted version. In typical Kubernetes land, if you do a deployment, what you would do is you will have one deployment with, say, 5 replicas. And the moment you want to introduce a new deployment, even if you do one replica of it, that one replica versus 5, that means out of total, 1 out of 6. So essentially, it's getting about 16% of traffic at least. You don't have the granularity or the control that give only 5% of the traffic. So how does like a service mesh like Istio really solves it? It basically relies upon the concept of a sidecar. And to me, when I started learning about the sidecar containers, I don't really see the need of it. But the moment you think of a sidecar container in context of service context, that tube bulb kind of clicks, this makes sense. And so what is Envoy, essentially? Envoy is a sidecar container, which is a CNCF project. So Envoy is a sidecar container that can be injected into your each pod of the application. Okay? Envoy was really created by Lyft, and it's a C++ lightweight proxy, about 40 megabytes written in C++, and highly scalable. They've been able to do up to 2 million requests per second using Envoy. So essentially what happens is you have your Kubernetes manifest. To the Kubernetes manifest, you say, take this manifest automatically. Remember, we looked at our manifest here. So if I go to greeting deployment, in here I'm saying spec has a containers, and I'm giving only one container in here. So what I will do is I will take this manifest, I will feed it to a Istio kernel. Like there's a kube kernel, there's an EKS kernel, there's an Istio kernel. So you will feed this manifest to Istio kernel CLI, which will generate a new Kubernetes manifest for you. And as part of that new manifest, it will automatically inject the Envoy proxy. So imagine your entire application is running hundreds of containers, each container, or hundreds of pods, and each pod has an Envoy proxy injected into it. Now, the concept of sidecar is that the containers in a pod can talk to each other using localhost. Imagine your application is running, let's say a name service needs to talk to a greeting service. So they will not talk to each other directly. Instead, each application pod or each application container in the pod will talk to Envoy. And then the Envoy proxies are the ones that are responsible for network traffic. So each application container talks to Envoy proxy. Then the Envoy proxy knows, oh, you want to talk to that and such service. So let me go to such and such service, resolve the pod, talk to the Envoy proxy. Then the Envoy proxy talks to the local application container using localhost. And that's how the communication goes. Now think about from the infrastructure perspective. The entire network traffic is really going through Envoy. And that you may think is overwhelming, but that gives you a lot of control. Because now you can say, oh, I want only 5% of the traffic to go to the new version. Or I want to enforce certain policies. And so let's take a look at some of those advantages. So this gives the basic instructions. Istio is not the only service mesh. There are other service meshes as well. But this is by far is the most prominent one that is used in the Kubernetes land. You can very simply install Istio on EKS as well. So I kind of give the instructions for that. What makes it simple is also that you don't have to use Istio kernel to generate a new Kubernetes manifest. You can simply say that, oh, by the way, in such and such namespace, use this particular, if any pod is created, automatically inject a kubectl or an Envoy proxy in it. So then my developer workflow basically looks like I've enabled Envoy proxy injection as part of that namespace. Then I'm just going to say kubectl apply manifest app.yaml. That's it. Or a Helm chart, so it'll automatically inject the proxy for me. So now, essentially, if you look at it, if I say kubectl get pods on this particular JSON path, it's showing that the greeting pod has essentially 2 containers, even though my manifest has only 1 container specified. Okay, same response, but now let's look at the advantages of what really works over here. So here is my app, Hello Howdy. And what does it do? Well, it's exactly the same app. I'm saying greeting hello. In this app, I'm saying this particular manifest has 2 labels, app:greeting and greeting:hello. And I'm saying the image name is Arun Gupta /greeting:hello. because that image returns a response hello. Port 8080. Then I have a greeting howdy, which basically it has app:greeting and greeting:'howdy. And it has a different tag as well. Okay? So the difference between the two is one of them returns a hello response, one of them returns a howdy response. Okay? In my service, now remember, this has two tags, app:greeting, greeting:'hello. And this has app:greeting and greeting:'howdy. In my service, I'm saying the selector has only app:greeting. So now I can scale the number of pods up and down dynamically between hello and howdy. It doesn't matter. All of those pods, they both have app:greeting as a label, and they will be included as part of the service. Okay? So what happens is, by default, if they have one pod, and if you invoke the request, it'll just round robin between hello, howdy. So that's like 50% split. But because we have Istio enabled, I can deploy new manifest to my Kubernetes cluster. And in this Kubernetes cluster, essentially what I'm saying is, one of the weird things about Istio is it's still v1 alpha 3. So seems like a pretty early version, although it has been out there for a long time. But what I'm doing is I'm creating a virtual service. And in the virtual service, I'm specifying the host. The host in this case is the service name that is specified in my Kubernetes manifest. And then I'm saying I want to create two destinations or two routes. Okay? For each route, I need to specify the destination. And I'm saying same host, but a subset is greeting hello and a subset is greeting howdy. Now I'm specifying weights between them, 75%, 25%. Okay? And how are these identified? Ultimately, they boil down to the labels, essentially. So greeting hello says greeting hello, and greeting howdy says greeting howdy. So think about it. One app has greeting hello, one app has greeting howdy. They're both part of the service because they both have app:greeting. That's sort of the lay over there. And now here, in my destination rules, I'm segregating them by greeting:hello and greeting:howdy. And that's how I'm defining 75-25 split. So from your developer workflow, you built your application, you built your Docker image, you run the container, you test it, you create your Kubernetes manifest, you create a Helm chart, you deploy the Helm chart, you want to do some A/B testing, so you enable Istio on your cluster, and then you say, okay, I want to set up the default namespace injection. You enable that, and then you say, now deploy, create these resources. So every time, essentially, when you are trying to do A/B testing, you will set up these deployment rules. And these deployment rules are dynamic in the sense your cluster is up and running, your application is up and running. As you change the rules, you can start with, say, 95.5, and then you can say slowly take it up from 95.5 to, say, 75.25, based upon your health metrics, and then grow it up from there. So it really simplifies on how you can do this traffic shifting. Now, traffic shifting is just one of the benefits of Istio. There are a lot more things, fun things that we can do with Istio, essentially. Well, we talked about canary deployment. It also comes with free distributed tracing. Very, very helpful, particularly if your applications are written across multiple languages. Otherwise, if you have to do distributed tracing, you have to use each application's individual framework, potentially using multiple languages. So it really avoids, as I was saying, that application framework explosion on your side. It also gives you metrics using Grafana dashboards, so you can start leveraging pre-built Grafana dashboards. Now, the last thing that I want to talk about briefly here is the deployment pipeline aspect of it. So two projects that I particularly closely watch and I love particularly is, one is Scaffold. Scaffold is by the Google container teams, and it really runs very nicely on your local machine. It watches your repo. It ties in with the Jib plugin. You can say that, all right, anytime I make a change in my application, invoke the plugin, Jib plugin or Dockerfile based, build a Docker image and push it to wherever you need to push it to, and then deploy the Kubernetes manifest as well. So go back to the point where you make a change in the IDE, and it automatically deploys your application to the cluster. So you don't have to worry about the undifferentiated heavy lifting. So that's one project definitely to watch. The second project that I particularly love is Jenkins X. How many of you are using Jenkins in your daily life? So you should definitely look at Jenkins X in that case, because Jenkins X really simplifies your app development experience, particularly from Kubernetes perspective. So essentially what you do is you take a Kubernetes application or a Java application, and you have Jenkins X up and running. So let's actually look at the website for a second. jenkinsx.io. So it's a simple CI/CD solution for cloud applications on Kubernetes. So all you're doing is essentially you take a Spring Boot application, and you can say, you know what, import this application into JenkinsX. It generates the Kubernetes manifest for you. It sets up Jenkins for you. And it really provides a seamless experience. So if you are somebody who loves Jenkins, definitely watch out this space. The community is very responsive. The cloud-based company, they have a commercial product on top of this if you want support. But that is for you guys. But I love the JenkinsX open source nature of it. And I know the team really well, so I get good response time. I think in an open source project, that really matters a lot. So let's go back here for a second. So let's quickly recap here, OK? So in terms of a Java application developer's journey, what you do is you start with the Java application. You make sure the application works correctly. That is, of course, upon you. Then you Docker package it. And we discussed sort of the different options around Docker packaging, Jib or Docker Maven plugin by the Fabric 8 team, or Dockerfile, multiple ways by which you can do this. Once you do it, then you write Kubernetes manifest. Once you get a feel for it. And the important part is you may not want to jump onto Helm chart right away. You want to feel the pain that I really need a Helm chart. And don't just say, I'm going to reinvent or over-invent the wheel. So write a Kubernetes manifest, then you see the relevance of it. Then you say, OK, I'm going to go to the next step, which is basically writing the Helm chart. Then you say, OK, my Kubernetes application is working. I'm good with the local cluster development. Now let me move to the cloud. So fire up our Amazon EKS cluster, run it up and there, over there. By the way, JenkinsX really works well on EKS as well. So that's a good part over there. It's very seamlessly integrated. You can, once you moved your application to the production cluster, you can fire up an Istio service mesh over there, start doing your canary testing, A/B testing, distributed tracing. All of that comes free as part of it. And of course, for the deployment pipeline, we talked about Scaffold and JenkinsX. In addition, we, of course, AWS also has managed services. So we have code pipeline, code deploy, all of those tools that comes where you don't have to manage anything. Click of a button, you deploy the service, and it's a fully managed service for you. So I hope you find this useful. Once again, as I said, this is sort of the repo where all the code is available. I would more than love to see any issues. What is it that we should be talking about here more? What kind of use cases that you would like to see? And if you want to send pull requests, we're all for it. Thank you.